In this video, we'll generate the dataset, trend line, and trend line equations of negative ln1 minus x. We begin with the dataset using array formula. Array formula minus ln1 minus x. And that's our dataset. Next, we generate a Taylor-Maclaurin series sum expansion, where it is the summation of a times x to the power k, where a is 1 over k. And our values of k is from 1 to infinity. So we have 1 to infinity. And we generate the Taylor-Maclaurin series sum, array formula, series sum of the x values, raised to the power starting from 1, incremented by 1, and the coefficient will be this range. Next, we work on the coefficient, which is array formula, 1 over k. So this will match our data set, almost match to our estimate approximation. Then we generate the regression coefficients using the 1 comma x matrix. We begin with the power transpose 0 to 8, or 1 to 8. And we can now enter the 1 comma x matrix. So array formula of the x values raised to the power 0 to 8. Now we can enter the LINEST, starting with the function itself, LINEST, data y, and data x. And the Taylor-Maclaurin series expansion. So LINEST, data y, and data x. At this time, we can chart this, insert, chart, to compare our trendline equation coefficients against the regression coefficients. Use scatter chart, and we generate the trendline polynomial to the 8th degree. Show the equation as label. And the legend, we move it at the bottom. And then we compare our trendline equation with our regression coefficients. Here we have the trendline equation, the coefficient of x to the 0, 8.34 times 10 to the minus 7, 7.39 times 10 to the minus 8. They're about the same. They're all 0. And the coefficient of x1, x is 0.942, 0.994. Coefficient of x squared is 1.92 and 0.662. Coefficient of x cubed is 12. That's 13 and 1.22. Coefficient of x to the fourth is 63 and 7.19. Coefficient of x to the fifth is 168 and negative 21, negative 168. Coefficient of x to the sixth is 253, and here is 34.1. Coefficient of x to the seventh is negative 202 and negative 29.2. Coefficient of x to the 8 is 68, and the other one is 11. While they may vary, but they're still on the same trend line. And our data set are almost the same because our approximation, which is the Taylor-Maclaurin series sum, almost equal to our function of negative ln times 1 minus x. This completes the use of series sum, array formula, and LINEST polynomial regression of the dataset of negative ln 1